Hi all, in this video I wanted to talk to you about the standardized statistic from section 1.3, how to find the z-score. The standardized statistic or z-score is given by the formula observed statistic minus the mean of the null distribution divided by the standard deviation of the null distribution. So in this particular handout I posted the key already in the modules. If you haven't seen it yet, you should definitely go there and look for it. So we recap in here two of the examples we did: the water bottle versus tap water study, and also the baby study. So as you go through, you see that I recap what we did with p-value, and p-value gives us one way to make a conclusion about whether we have statistically significant data or not. And the other way is the standardized statistic. And so here I have the definitions for both. The p-value is the probability of getting a statistic as extreme or more extreme than the one observed in our study. And the other way is the standardized statistic or z-score. And they should both give us the same exact result. Observations that fall more than 2 or 3 standard deviations from the mean are considered extreme. And in the key, you should have seen my little graph. So in here, I talk about what I want to show is the strength of evidence against the null hypothesis. Remember, the null hypothesis is a what if scenario. What if things are happening by random chance alone? And so if observations fall more than 2 or more than 3 on either side, right, 2 or 3 to the right, 2 or 3 to the left, the minus just means you're to the left tail, then that's considered strong to very strong evidence against the null hypothesis. Against the null meaning against the claim that things are happening by random chance alone. So here's a little guidelines for evaluating based on your z-score. And so notice that if you're below -2 or above 2, so that's the green line here, and if you're below -3 or 3, so that's the black line on the graphic, that is equivalent to having a very small p-value. So that's why a very small p-value equates to a large z-score. Both of those tell you that your statistic, your p-hat, is in the tail end of the distribution, very far from the mean. So going back to the tap water versus bottled water example, when you go to the one proportion applet, we can see, and this is, I did it based on 10,000 repetitions, and we're trying to gain some, our p-value was 0.065, which only gave us some evidence against the null hypothesis. Which then means, since I only have some evidence against the null, when I find my z-score, it should be in the moderate evidence against the null hypothesis. They should give us the exact same thing, and notice that we get 1.67. And just to review how to do the one proportion applet, so go to your applets, and for the tap water, there was 1 cup hot tap water out of 4, so that means the probability is 0.25. There were 27 people at the festival, so we will change that to 27. And I want to do 10,000 repetitions, so I'm going to put 10,000 there, no comma, and unclick animate so that things come out a little faster. And the thing with the one proportion applet is you always want to make sure that you have proportion of successes clicked in. And draw samples, and so it gives us a nice and symmetric distribution. And so we want to count how many times does our statistic occur, something like our statistic or as extreme, so greater than. And you can go back to the handout and look at what was our alternative hypothesis. And our alternative hypothesis was that the proportion is less than 0.25. So I'm actually going to be looking at things that are smaller. And there were 3 out of 27 people had chosen the tap water as their water of choice, so 0.111. So when we go back to the one proportion applet, that is my statistic. So 0.111, and make sure that this sign, this symbol, matches our alternate hypothesis, which was less than. So I'm going to change it to less than, and there's my p-value, 0.0647. When I did the handout, I got different. I got a different result. What was our p-value? 0.065. But notice that is still very close. And so that gives us some evidence against the null hypothesis. And you can go back to the section 1.1 where I gave you all the guidelines for p-value evaluation. Now the standardized statistic, we do the observed statistic, so that's our p hat, the 0.111, minus the mean of the null distribution or our hypothesized mean. Our hypothesized mean is the 0.25, what we think would happen by random chance, right? The null distribution is that what if things are happening by random chance. So if people are choosing the tap water at random is 1 cup out of 4, so 0.25. The standard deviation is 0.083. That comes from after you've done the simulation with your 10,000 tries. Make sure that you click on summary stats, and there's the mean 0.25 and my standard deviation 0.083. And so that's what I put here, and that gives us a negative 1.67. Negative again just means it's to the left, which is what we want because we said less than. So we are 1.67 standard deviations to the left of the mean. So it's not enough to get us for strong evidence. Remember, strong or very strong, we have to be more than 2, either to the right or to the left. So here we're just at 1.67 to the left, so it's not quite strong evidence. So we have moderate. So the p-value and c-score give us the exact same thing. And so what kind of evidence do we have? We have moderate, which is same result as with the p-value. The second example is the baby study, and so I encourage you to do this on your own, and you should get results very similar to this. Again, the observed statistic is the 16 babies, right? 14 out of 16 babies chose the friendly toy, so that was the 0.875. The mean of the null distribution, or our hypothesized mean, in that case they were choosing one friendly toy out of 2 toys, so it's 1 out of 2, which is 0.5. And a standard deviation, once you do the one proportion applet, again put in your information, 0.5, 16, 10,000, count our statistic, and then make sure you click on summary stats so that you see the standard deviation right there. SD, that's what you want to use in the formula. And here I attach a screen capture for that one so you can see the mean and the standard deviation for your calculations. All right, I hope that these helps clear up any confusion you may have had, and it helps you with your projects.